Okay, welcome back guys. So this would be part 2 of the previous video. This is lesson 3.3, derivatives of product and quotient functions. In the previous video we discussed formula to find the derivative of a function that is defined as a product of two functions. So this is the formula here. We did several examples and an application. So now in this video here we're going to look at how to find the derivative of a function that is defined as the quotient of two functions. Let's start with the formula. So quotient rule. Okay, this will say that if we given a function, if f of x is a function of two functions being divided. So let's say this is the top function u of x, this is the bottom function v of x. So if this is the quotient function here, and also if the derivative of both u and v exists, and if both u prime v, u prime x and v prime x exists, then the derivative of the function f of x is equal to the following. Okay, it's going to be a quotient. The derivative is going to be a quotient. Okay, the part that I always remember the most is the denominator. So the derivative of a quotient is always equal to, I know the first thing is the denominator is going to be the v squared, the bottom function squared, and is gonna be the bottom function times the top derivative, which is u prime, and then minus right in the middle, and then it's gonna be the top function, which is u, times v prime, which is the derivative of the bottom function. Okay, so the quotient rule is equal to v u prime minus u v prime over v squared. Okay, so that is the quotient rule. Okay, so let's try some example. Okay, find f prime of x. Okay, so the first example we have is f of x equal to x squared over 2x minus 1. So we can say a u function is x squared and a v function is 2x minus 1. So u prime is 2x and then v prime here is 2. I usually start out by writing the formula so that way I know what to plug in. So my derivative is equal to v squared in the bottom, and then it's going to be v times u prime minus u times v prime. So I usually write that first part, and then I just plug in what I have on the right hand side here into the formula. Okay, so I'm going to say equal, all right, v is going to be 2x minus 1 squared, and then v is going to go right here first, and then u prime is going to be 2x minus u is x squared, v prime is 2. So now my answer is going to be 4x squared minus 2x squared over 2x minus 1. We usually don't simplify the denominator. We leave it as how it is, and hopefully there's things to cancel to the numerator. So 4x squared minus 2x squared is 2x squared minus 2x over 2x minus 1 squared. So if we were to factor out a 2x on the numerator, then if there's thing cancel to if there's a common factor in the denominator, we cancel out. But in this case, there's nothing cancel out. You know, if you factor out 2x there, we get x minus 1, and nothing really cancel out there. So we'll just kind of leave the answer how it is. Either you leave it in this form here or in that form, it doesn't matter. Okay. All right, let's do another one. Let's do b. Our function is let's use t, f of t. F of t equal t squared minus t over t to the third plus 1. Okay. So again, my u is the top function, and then my v is the bottom function. Let's take the derivative of those. 2t minus 1, 3t squared. So now, let's plug that into the quotient formula. We know that it's going to be v squared in the denominator. And it's going to be v times u prime minus u times v prime. And then we plug these derivative on the right side here in. So v is t to the third plus 1. U prime is 2t minus 1. Minus u is t squared minus t. And then times v prime is 3t squared. Alright. O over v squared is t to the third plus 1 squared. Okay. Now let's simplify here. In this case, we may want to, well, let's see if this thing's factor out. There's no common factor there, so I guess we can't really factor anything out. We just have to simplify this. So I'm gonna go ahead and FOIL out, okay? Let's see here, we can FOIL it out, so that would be 2t to the fourth minus t to the third plus 2t minus 1 minus 3t to the fourth plus 3t to the third over t to the third plus 1 square. And then that's simplified into 2t to the fourth. Actually, no, it's going to simplify into, let's say we got this term and that term, so that becomes negative t to the fourth. And then we have plus 2t to the third plus 2t minus 1, and then over t to the fourth plus 1 squared. All right. Let's do one more example. All right. Natural log of x over 2x plus 5. Okay. All right, so let's list our u and v. U is ln of x. V is 2x plus 5. U prime is 1 over x. V prime is 2. All right, so y prime is v squared. V u prime minus u v prime. All right. U squared is 2x plus 5 squared. V is 2x plus 5. U prime is 2 minus u is ln of x, and then v prime u prime is 1 over x. I think I did this one wrong. Okay, let me go back just a little bit. All right, so v is 2x plus 5. U prime is 1 over x. There it is. All right, minus u again is natural log of x. V prime is 2. Okay, so let's simplify this here. So we have 1 over x times 2x plus 5 minus 2 natural log of x over 2x plus 5. We usually don't leave fraction within fraction in a complex fraction situation here. So in this case, we want to simplify the numerator. So what we can do is we can times this by x to cancel out the x on the top there, and then we also need to times the denominator by x to make sure that we have a factor of 1. Otherwise, we're gonna change the problem there. So now that gave us the answer. The answer now becomes 2x plus 5 for the first term minus 2x natural log of x over x times 2x plus 5 squared. Okay. And that's as far as we can go. Okay.